The Perez company has the opportunity to invest in one of two mutually exclusive machines that will produce a product it will need for the foreseeable future. Machine A costs $10 million, but realizes after-tax inflows of $4 million per year for 4 years. After 4 years, the machine must be replaced. Machine B costs $15 million and realizes after-tax inflows of $3.5 million per year for 8 years, after which it must be replaced. Assume that the machine prices are not expected to rise because of inflation. What will be the offset by cheaper components used in this machine? The cost of capital is 10%. So we have to identify which project to invest in. There's two different ways we can do this. We can do this by using equivalent annual annuity approach or replacement chains. This first approach is going to be the equivalent annual annuity. To do so, we find the NPV for project A or machine A and machine B. So machine A has an NPV of $2.68 million approximately, and $3.67 million for B. We then figure out the annuity payment that would give us this NPV over a 4-year period. Then we figure out the payment for an annuity that would give us this NPV over an 8-year period. So use the payment function. So machine A is for 4 years. The present value and the future value will leave as 0. So we see that the annuity of $845,291 and change per year for 4 years has an NPV of $2.679 million. So we change the payment to enter for the payment function for machine B, we have to change the number of periods to 8 years, which is $688,339. For those of you who are having a hard time understanding what this means, let's say we took this amount, hit F4, and we get this cash flow for the next 4 years. We can then use the function NPV, again using the discount rate of 10%. We can value these 4 cash flow payments. And we see that this annuity stream, when discounting at 10%, has a present value of $2,679,461. If we were to take 688 and drag it out for 8 years and find an NPV discounting at 10%, we would then find an NPV of $3.672 million. What this tells us is, what is this project worth on a year-by-year basis? So using this annual annuity, we can see that even though B looks better with a higher NPV, we can see on a year-by-year basis we get more money from project A. The other way is to identify that we could buy machine B again. Machine A in year 4. And what would happen is we would have a 10 million outflow at time 0, followed by a 1 million, or followed by 4 million, 4 million, 4 million, and 4 million. But again, in year 4, we'd have to buy the machine again. So 4 million less 10 million going out results in a 6 million deficit, followed by 4 million, 4 million, and 4 million. We then can just take the NPV. We'll copy our formula down, and we see that when we do replacement machines approach, the NPV of A is approximately 4.5 million, and again, we already know the NPV for B. It's the same as up here at 3.67 million. So we would obviously prefer machine A over machine B.